So I'm writing this for team 9, team D, and it's project 9. I just wanted to show you something that I hoped I could have shown you on Monday on a Blackboard, but since you weren't there, I will just record it now because it's something that's very difficult to, as you will see, very difficult to do in sort of standard mathematical notation. So I just want to make sure that you have the same picture as I do for the setup of your project. And I'm going to do a little drawing, which is closely related to one that is in the project catalog. But I will use colors for reasons that will be obvious in a second. So I think these are the colors I have chosen. So, I mean, the way I want you to think about this is that you have sort of one big graph, which is specified by the matrices A, B, R, and S. And you should think of them as sort of A lives in one component and B lives in another component, and then R goes from A to B and S goes from B to A. So, so the project has to do with these special kinds of shift equivalences, and there's this notation phi S is relating, and I'm using these colors carefully now, something that starts in B and then goes across with S. I don't know why I wrote it like that. So it starts in B and then goes across with S. That is related using this map phi S to something that goes first S and then A. Right, so you can see that in both of these cases you sort of start in B and end in A, and the assumption of shift equivalence says that there's an equal number of paths of these types, and then you sort of make between any pair of points, and then you take an explicit choice of an isomorphism between them. Okay, so this is phi R S, and there's also something called phi R. I mean, these are specified, you know, in they start somewhere and end somewhere else. It doesn't really matter for what I'm doing here, so I will be a little bit sloppy. That's what I mean by this back and forth. I mean, you're going to have to define this as a map. You have to decide on a direction for this to go, but it doesn't really matter. So this is this one here, and then I have psi A. Psi A is a little bit more complicated. It associates something that looks like this to something that looks like this and has the length that we call lag. So this is different in the sense that psi A will take something that, oops, I did the colors wrong. I have to change that. So down with green and up with red. And then it takes something that sort of starts in A, goes down to B, and then up again, and associates it to a path that has length M entirely up in A. And then, of course, there's also something called psi B, and it goes the other way. So it associates something that goes first up and then down to something that lives downstairs and also has the length. Yeah, I'm sorry, I have to change these colors all the time as I write. Okay, so so I mean, this is essentially just drawing the definitions that you see in the project catalog. But I want to also draw the key assumption that we're discussing in this project because I think that is instructive. So the way I would like you to think about this is that you start with something that looks like this. It's one of these paths upstairs in A, and then there's an edge coming down. And just like before, the length of this is M. And the point is that now there's sort of two different things we can do to this element. And the one thing that I'm going to do is associating something to it using only phi s, right? And phi s, of course, sorry, that's phi r. Using only phi r, right? And what is it phi r does? Well, I mean, you can sort of think of it this way, that if you first look here, here's exactly one of these elements that phi r acts on. So I'm going to leave the first m minus 1 steps up in A, B, and then I'm going to apply phi r, right? And phi r takes something that lives, I'm just going to draw like this, it lives up here and associates it to something that lives here, right? But let me remove it again because it's noise. So so what happens here is that I will just take this thing that used to be purple, then green, and then I will replace it by something which is green, and then blue. Okay, I made a mistake here as well. This, of course, has to be blue. Confusing myself. Okay, and then the point is, of course, I can do this again, right? So I can do this again in the sense that what just happened is that I used phi r in order to associate these two things that I highlighted in gray. But now I can do this again. I have this thing that I'm highlighting in black, and I can apply phi r to that. Right? So that gives me purple, 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 and then something down in green, and then something in blue, and then the blue thing I had before. Right? So this is what I'm associating this time in black. And of course, the point is that I can keep on doing this, right? So I can keep on doing this, and this is what we're calling phi r m. So at the end of the day, I will just have something that comes down in green, and then a bunch of blue. Right? So you see, this is one thing that I can do to this element. But I can also do something else, which is a little bit faster. So I will take the element here and I will write it again, right? So I'm thinking of these two things as the same. And now I'm going to apply first psi a to this. How can I apply psi a to this? So of course, just as before, this is m long, right? But psi a is something that associates a path of length m to something down up, right? So when I use psi a, I get down, up, and then I have the green thing that I had before, right? So if I'm highlighting the way I did before, then, oops, I'm associating this thing here to this thing here. But then, now the point is that I can also use psi b, because psi b allows me to act on this thing that I'm highlighting in black now here. I leave the green thing fixed, but psi b associates exactly to this something that has a path of blue of length m, right? So you see the point of this whole concept that we're talking about is the non-trivial condition that these things are the same, right? So I will start with two things. I will start with one thing that I'm highlighting now in hot pink, right? This is the same, and I'm doing two different things to it. Right, and I get something out which I will highlight now in yellow. And it's not obvious, and in fact not always true, that those things are the same. Right? But we're looking for a choice of the phi's and the psi's so that this becomes the same. And this is what this project is all about. So that's what I wanted to draw for you.